Alright, okay, let's look at this question. This was a simple question, but it's a question that I want to explain what is meant by dependent event, right? It's a non-independent event. So look at the question here, pause the video and try to use some methods to solving this problem here. So a box contains 7 red marbles, 5 yellow marbles, and 3 blue marbles. 2 marbles are chosen randomly from the box. One by one from the box, one by one, right? Sorry, it's randomly one by one from the box. If the marble is blue, the blue marble is then returned to the box before the second marble is chosen. If the first marble is not blue, the marble is not returned to the box, and then the second marble is chosen. So it's a combination of independent event and dependent event. I'm going to tell you what is meant by that. So you look at the diagram. You must know that how many yellow balls, right? How many yellow balls? So yellow balls we have 7 marbles. Sorry, 7 yellow marbles, and 7 red marbles. Alright, red marbles we have 7. Yellow marble we have 5, right? Yellow marble we have 5, and 3 blue marble, right? Total up you have 15, right? 15 marbles. So 2 marbles are chosen randomly from a box, right? One by one from a box. So means that this is an event after an event, right? Means that event by event. So means the first event is either you choosing a red marble, yellow marble, or blue marble, right? Means that first you choose one, right? First the event. So means that these 3 are actually mutually exclusive event. When they come from one event, it's mutually exclusive event, because either you choosing the red is 7 out of 15, or yellow you have 5 out of 15, and blue marbles you have 3 out of 15. If you total up this probability, you are getting 1, right? You are getting 1. They are mutually exclusive because that only one ball is taken, right? You must understand the meaning of mutually exclusive. When you take one ball, right? The ball either is yellow, right? If it's yellow, it could not be blue or red, right? So means that it's either one of the color. So means total up of these 3 will be 1, right? So it's look at the probability here, okay? So later on, from this second drawn, right? Second drawn. So if, look at the question. If the first marble is blue, the blue marble is returned to the box before the second marble is chosen. Means it's replaced, right? The blue marble is returned to the box. So means that for this, the second drawn, right, is also will be red, yellow, and blue. But because of the first drawn, you get is blue, right? The blue marble. The blue marble you return back to the box, right? Return back to the box and you take another marble, right? So means that the total is still will be the same. The total number of balls in the box is still will be the same because you return to the box, right? So means that the red will be still have 7, right? 7 red, 5 yellow, and 3 blue, right? This is independent, tidak bergantung. Why? The probability for red getting and red, right? The probability of getting red depend on B, right? It will be the same as the probability of red. 7 out of 15, right? Because the total number is do not change, right? Do not change. It's not affected, or we said that the result here will not affect here. The second drawn, right? They are independent. But for this, if the first marble is not blue means either yellow or red, right? The marble is not returned to the box. Not returned to the box. So, all right. So what is the meaning here? It means that it will be red. The second draw also will be red, yellow, and blue, right? Red, yellow, and blue. This one also will be red, yellow, and blue, right? Red, yellow, and blue. But the total now become 14. become 14 for each of these, right? Become 14, become 14, become 14. Okay, you try to pause the video and think why it become 14, right? Why it become 14? Because if you get red or yellow, the marble is not returned to the box. So it's not returned, you put somewhere. So inside the box, you still have 14, right? 14 marble, right? 14 marble. So, but for this case here, the red will be reduced by 1, right? Suppose you have 7, right? Because you've taken the red ball. The red ball, you are not putting back, right? So means that the red ball also reduced by 1. Means from 7, it becomes 6. But the yellow marble is still to be the same, 5, right? The yellow marble will still be the same, 5, and blue marble will be 3. Hope you understand. And same thing for this. The first marble take is yellow, right? You take yellow. Okay, if this is yellow, not blue, I put outside, right? So I still have 14 ball, right? So but the red inside the box is still have 7, right? 7, and the blue will still have 3. But the problem is the yellow is reduced from 5 yellow because you have put outside. So means that put outside the box, then you still have 4, right? 4 more, right, for the yellow. So total up, you see, 7 plus 4, 11. 11 plus 3, you have 14 ball, right? Total up, plus 6 plus 5 plus 3, you have 14, right? So this is a tree diagram. So means that with the help of tree diagram, it's actually helping us to solving this problem here. Alright, okay. I hope you understand what I'm explaining here. The most important, you understand the question. Alright, okay, look at this. The probability of getting 2 marbles of different colors. So means that you have how many possibility here? You have red, 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 yellow, right? So the first is red, the second one is blue, right? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 outcomes. 9 possible outcome for 2 events, right? The 2 drawings here. So it means that getting 2 marbles of different color. Which one? Right? This is same color, right? So this one, right? These 2 means of 2 different color: red, yellow, red, blue, yellow, red, yellow, blue, right? I put a star here to tell you that it's actually come from these branches. So, and this also blue and red, blue and yellow, but not blue and blue, same color, no. So it's the way how you calculate this. There is 2 ways of doing this, right? One is you add up, you multiply, plus this one multiply, plus, but you need to add up 6 times, right? 1, 2, 3, 4, 6 times. So it's tired. So I will use the other way. So the probability of getting getting 2 marbles of different colors is therefore equals to, I will use the concept of 1 minus the complement, right? The concept of complement here. I take 1 means that total up all this you have 1, right? The probability of 1 minus away, they're getting the same color, right? So it means that 7 over 15 multiply with same color, red and red, 6 over 14, minus away yellow and yellow, right? Yellow and yellow, 5 over 15 multiply with 4 over 14, right? 4 over 14, and minus away blue and blue, right? Blue and blue, 3 over 15 and 3 over 15. Another thing I want to tell you, this is a dependent event. This first 2 is the dependent event, right? It's depend. The next event depend on the first event, right? Because why? If you get red, the number of red will be reduced, the total will be reduced. But this is independent because it doesn't affect the next result of you getting red. But this is affect. First you get red, you get 7 or 15. But the next one you get red is 6 or 14. It's affected, right? It's called independent, right? Sorry, it's called dependent. And this is independent. So, alright, if you minus all this, you are getting the answer, right? You are getting the answer. Why am I taking 1 minus? Because 1 means every possibility. Minus away the probability that you're getting the same color, right? So means that the rest will be, this will be getting double red, yellow, yellow, blue, blue, right? And the rest will be the probability for different colors, right? Okay, let's calculate. Right, you were getting 349 divided by 525, right? So this is a probability for question A, right? Part A. Alright, okay, let's look at the next question. The question is getting yellow marble in the second round, right? If it is known that this is the meaning of conditional probability. Alright, how to use tree diagram? How to use tree diagram to find conditional probability? This is the way. Given yellow marbles in the second round, if it is known that the one that behind here, right, that getting two marbles of different color. Get two marbles of different color is the one that I put star here. Can you see that? The put star here, which is 1, 2, 3, 4, 5, 6, right? 6 of them. Do you still remember part A? You are getting the total probability. Means that the probability for 1, 2, 3, 4, 5, 6, the total up will be 349 over 525, right? So means that the probability getting the probability of getting the yellow marbles, right? You just write there probability of blah blah blah, probability of getting yellow marble in the second round. If it is known that the getting two marbles of different colors, means that this is very important now. You must know what is the probability here. If it is known that getting two marbles of different colors, right? You see the probability of getting two marbles of different color is 349 over 525. Means that you have to divide by this probability. Means that 525, right? The total of this 6, right? Of this 6. Now, the question is asking us to find the probability of getting yellow marble in the second round. Okay, if it is known that getting two marbles of different color, means out of the 6 branch here. So daripada 6 kemungkinan ini, mana, jangan tengok yang lain. Don't look at other that are not putting star here. This is different color, right? Different color. So that's why the total from different colors is this. So out of these 6, the conditional probability meaning that out of these 6, which one is the second drawn is yellow, right? Means that getting yellow marble in the second drawn, which is belong to this one, right? So I put a tick here, right? The second is getting the yellow. No, the second is getting red. No, the second one is getting red. Getting blue, right? The second one is getting blue. Yellow, red, yellow, blue. So this is not, right? Not this, not this, not this, right? The second blue and red, right? No, not this. This one, the second drawn is yellow, right? Now the second drawn is yellow. So it is. So means that the probability of these two add up, divide by the total of this 6 star. This meaning here, all right? This is the meaning of conditional probability. So means that you take 7 over 25, 7 over 15, sorry, 15 multiply with 5 over 14, right? 5 over 14 plus or maybe this one, first one blue, second one yellow, right? Or first one red, second one yellow. So first one blue 3 over 15, second one blue will be 5 over second one yellow is 5 over 15, right? So if you take up all this probability total, divide by the total, then you will know the conditional probability for this event, which on top here we're giving us 7 over 30, whereas this will give you 349 over with 525. So if you divide these two, the probability will be, right, which we're giving you 245 divided by 698, right? 698, which you can actually rewrite in decimal form, but in 3 significant figure it will be 0.351, the probability for this, the conditional probability for this event here. All right, Hope you understand the meanings of using tree diagram to finding the conditional probability. Alright, that's all for this video.